Okay, so here's the third part of part 3 of SPSS 2. So hopefully you're following along. We're on finishing up null hypothesis significance testing with an example from Clark and Stoner. So recall from that article that they were looking at the spelling ability of Braille readers, and their null hypothesis was that the mean for the Braille reading group was equal to 100, which was the same as the normative sample that was used to norm the results from the spelling assessment that they used in that study. Then their alternative hypothesis would be, if they reject the null, they would accept or they would suspect that a hypothesis would be true that the mean for the Braille readers was not equal to 100. So hopefully you recall from our one-tailed, two-tailed test discussion that this is a two-tailed type of alternative hypothesis in that it doesn't have direction. It's not greater than or less than, but instead they're just saying that if we reject the null, then we would know that the alternative hypothesis that there is a difference between the groups would be considered. So just to remind you of the results from their study, they came up with a t-value of negative 0.410. And then based on that t-value, because of the magnitude of t, it produced a p-value that was greater than 0.05. So since the p-value was greater than their alpha, which they set at 0.05, then they said, well, we don't reject the null hypothesis, and so therefore we're going to assume that the mean for Braille readers is not different from 100. So one of the things that Yaki does is that he reports p-values like this, p is greater than 0.05, which back in the old days, in Fisher's day, when they only had tables of 0.05 and 0.01, they couldn't really say much more about it than that. But since most everybody does their statistical analysis using some sort of software like SPSS, we can actually publish exact p-values. And in fact, APA requires that we do that. So what I did is I went back and I analyzed the Clark and Stoner data using SPSS. And so here's the output of the one sample t-test from SPSS using the data from Clark and Stoner. That was nice of them to actually publish that, because a lot of times people don't actually put the data in there. So this made it kind of nice. So you can see that there is a lot of information here about that. So let's just take a look at some of the key values that are in here and talk through how you might interpret these results. So let's start with the mean. And so we can see here that the mean is 99.00, and you recall that for the Braille reading students, they had a mean of 99 on the spelling test, the test of written something skills 4, part 4. And then here's the standard deviation, so that tells us something about how spread out the data were. And then down here in the second table in the output, it tells me what the results of the one sample t-test was. It tells me the test value. So part of the process of entering the analysis, you say, well, what do we want to compare this mean to? So you can see there that that test value was 100, which was the overall mean for the normative sample on the spelling assessment. Then down below, we can see what the value of t was. And so as they presented it in their paper, we can see that we can verify that it was negative 0.410. Now that could be expressed as a positive number. It really doesn't matter because you're subtracting 2, and it just so happened that the mean for the Braille reading students was less than the normative mean, so 99 minus 100 give us a negative number, so that's why t is negative there. Degrees of freedom tells us something about our sample size, and recall that our sample size was 23. We can see that right up here. So in doing a t-test, the degrees of freedom is actually 1 less than that. It's 22. And so that's something to also take into consideration, that's something you'll need to report as part of the results of your study. Then here we've got a column that says SIG two-tailed, and recall that SIG translates in SPSS to the p-value. So this is our actual p-value. Remember that Clark and Stoner reported p was greater than 0.05. Well, this table shows us exactly what it is, and according to APA and the treatise manual, you should report the exact significance for that particular test. So that's some important information. And then this is the mean difference. So basically that's this 99 here minus 100 here. That's the difference in the two means that we're looking at. And then there's some other information here about the confidence interval that we might get to later and talk about that. But you'll notice that 0 is in that range there. So that tells you that it's not significantly significant difference between the groups. So that's kind of a little bit higher level stuff, but nonetheless it is interpretable. So let's sort of reevaluate Clark and Stoner through now what we know about null hypothesis significance testing and what APA says that we should do to report the results. And so we can see here the results of the one sample t-test in SPSS that our t-value is negative 0.410. That hasn't changed. But now I know the exact p-value, that it's 0.686. And just a note, you'll notice that there's not a 0 preceding the decimal point because p can only range between 0 and 1. So by convention, according to APA, we do not put a 0 in front of p-values. And then the third thing then would be to actually calculate the effect size. So that's something that we would need to do in our study. So we would, in this case, actually calculate Cohen's D, and that's provided for you in the Yaki text on how to calculate this. So you can see that there's in the numerator, there's the sample mean, and then you're going to subtract off the population mean. So the sample mean was 99, the population mean was 100, okay, and then we're going to divide that by the standard deviation, or how spread out the data are for the sample that was taken, in this case the 23 students who are Braille reading, and the standard deviation from our tables up there is 11.697. And so if we take 1 and then divide it by 11.697, we come up with this 0.085. And so Cohen came out with some rules of thumb to indicate kind of like they did, like Nunnally did for the Chromebox Alpha. This 0.085 is this very small effect size. It basically says that the Braille readers scores on the test was 0.085 standard deviations below those of normal sighted readers. And so that's a very small effect size, and Yaki will provide you with sort of these rules of thumb when they're available. And so part of your write-up for each one of these will include a discussion of the sample of the effect size and whether that's small, medium, or large, according to some sort of criteria that somebody's set out as rules of thumb. So the other thing that Yaki does is he gives you an example of how to write it up using APA format, which I think is very helpful to students who aren't familiar with doing this. And so basically what you need to do is simply take his kind of template for the example he gives and then plug in the information for the particular study that you're working on. And so as you can see here, this is what the write-up for the Clark and Stoner might look like using Yaki's write-up for the one sample t-test that he gives in chapter 5. So it says scores on the TWS4 for Braille reading visually impaired students, and then in parentheses it provides the mean and standard deviation for the data for that group. Did not differ significantly from the normative group of sighted readers, and then it gives the mean and standard deviation of that group. Now the mean is 100, standard deviation, they sort of define that like IQ tests, and I think I discussed this briefly in class. IQ tests have a standard deviation set to 15, and so I put that information in there. And then they give the actual statistical data. So it says T and then 22 in parentheses, you'll recall that that's the degrees of freedom for the t-test. And then it gives you the value 0.41. I took off the negative sign because it really doesn't have meaning. And then the p-value that was actually reported. Now here's something that Yaki will do incorrectly, is that right here he will put p is greater than 0.05. So I want you to know that, because when you do your assignment, I want you to do it the way that APA asks you to do it, and that is to provide the exact p-value, because somebody somewhere someplace might want to know what the p-value was that you got exactly, rather than just some nebulous p is greater than 0.05. And then finally you finish up by giving Cohen's d, and that's sort of universally known what that is, so you don't have to put the Cohen's part there. Notice though that p and t and d are all N and SD and M are all italicized, because remember statistics that when we put those in Roman face letters that we will italicize those according to APA. But you can see that the effect size there is 0.085. So that's just a brief talk on the what you would do for the write-up. And again, Yaki provides some clear direction on that, and so it's going to be really contingent upon you to figure out how is it that you're going to use that information to respond, take the data from that I provided for you for each of your assignments, and then do the analysis, and then take the results of your analysis and plug it in to kind of this template that Yaki has provided for you. Now, it doesn't have to be just lockstep exactly like he does, but he has most of the components correct in presenting those. You may also look at that section in your APA manual if you want some additional guidance on what that should look like. But notice that for this, there's not a table. And in fact, APA says you should not put a table in there unless you really need one. And so they're totally okay with putting all the statistics right into the text, into the paragraph that you're writing for your results. So what Yaki is going to do is give you a lot of practice with that, so that you'll know by the time we get done with this course that yes, indeed, you can do that, and you can use Yaki as a guidance. Okay, so that finishes this part, and I realize this was way long, but it really represents kind of the direction that all the rest of this analysis in Yaki is going to go, nearly without exception. So hopefully this will provide good foundation for you. Thank you very much, and tune in for the next part where I talk more detail about Chapter 6 on the independent samples t-test.